Howdy folks, welcome back to yet another video, and as always, let's get started right away. And this time we're going to compare fractions where the numerators are the same and sometimes fractions when the denominators are the same. And so there's some different skills and ideas that we need to think about before we do so. So different fractions of the same whole, they're the same size, same object, same pie shape, same bar shape, may have the same denominator, and then the parts being counted have the same size. So I have two bars here. One has, they both have 10 equal parts. They're both the same thing, but in the top one, only 3/10 or 3 colored squares are counted. In the bottom one, there's 9/10 or 9 colored squares are colored. So the fewer the parts, the smaller the fraction. And when I say fewer the parts, that means the fewer parts being counted. So you can see in the 3/10 there's fewer parts being counted, so it is a smaller fraction. So in this situation, 3/10 is less than 9/10. So let me say that again. 3/10 is less than 9/10. Now I'm going to pause here for a sec. I'd like to talk about these symbols, and you may have teachers that have described them in different ways. We read it left to right, so we know it's less than if it's this symbol. And I was always taught there might be a bird you can make out of this, and the bird always likes less food, so it points its beak towards the smaller one. You might have a teacher that's done the alligator, you make the teeth, and the alligator always likes something bigger to eat, so therefore we would say greater than. So in this situation here, this is less than because we read left to right. 3/10 is less than, the beak's pointing that way, to 9/10. All right, so here's one way to order these fractions with the same denominator. I have 3/8, 7/8, and 2/8. And like I said, I need to rewrite these sometimes just because of the way it's written. 3/8, 7/8, and 2/8. And so 7/8 is the greatest because it has the most parts being counted. The numerator is the highest. Now, this only works if the denominators are the same, and they're all 8. So we would look at the numerator. That is the greatest numerator. Therefore, it is the largest fraction. 2/8 is the smallest fraction, or the least fraction, because it has the fewest parts being counted. And so from greatest to least, it is 7/8, 3/8, then followed by 2/8. Now, sometimes the fractions could have the same numerator, and they're the same size, same object, same pizza pie, same bar, same length, but the denominators are different, and that's because they've been divided into different size pieces. So then the parts being counted have different sizes. So you can see in the top one, I do have 3/4. It is the same length as the one for 3/6. But the bottom bar has been divided into 6 equal parts. And so even though we're both counting 3 parts, because the pieces are larger, 3/4 or 3/4 is a larger fraction than 3/6. So we can say that 3/4 is greater than 3/6. 3/4 greater than, alligator eating the bigger one, than 3/6. All right, so there's a few ways we can order and, compare and order these fractions with the same numerator. Again, the denominator is different, and but I can't stress enough that the objects have to be the same size or same thing. So here I have bars that are the same length. If we're comparing pizza pies, I know I bring up pizza a lot, they have to be the same size. You can't have a large pizza divided into different pieces than a small. It doesn't make sense. So whatever the object is that you've divided up, when we're comparing the different objects, the piece sizes may be different, but the objects have to be the same size. And so again, in this example, I have 3 bars, and they're all the same length. The difference is I've divided them up differently. So there's 3/5, 3/10, and 3/4. Now, you can fold paper strips, and while that sounds great and wonderful, the paper has to be the same length, the same width, etc., which is, I guess, technically you can measure it out. But the problem with this method is you got to fold it exactly into equal pieces. So something like, quarters, you can divide in half and then half again. But if you're talking about something like fifths, that would be hard to fold. So I'm just going to visually show you what that would look like, and I'll show you an easier way at the end to kind of how to think about this. But you can see here that I have 3/4, 3/5, 3/10, and 3/4. The pieces are smaller, or I mean larger, because there's less pieces. So 3/4 is definitely the greatest. So for greatest to least, I have 3/4, 3/5, then 3/10. Another method is to draw number lines, and again, the number lines have to be the same length. And so again, this is one of those things where you have to divide equally. This method, if you're doing in your notebook, might be a little bit easier. You just draw the same length objects. And so I'm going to attempt to do this. So this is always 0, and this is always 1. We're talking about one object. And so halfway, let's say the top one is the tenths. The top one will be 5/10. And so I'd have to divide these into 10 equal pieces. So 1, 2, 3, 4, 1, 2, 3, 4, 5. So I already messed that up. And so you can see why this might be a little difficult. I have to divide this into 4. That's approximately okay. 6, 7, 8, 9. And so this is where 5/10 would be. Okay. And so I have to do the next one. Let's say I'm doing in 6. So this would be my 3/6. So I need to have these like that. And so I'm trying to find out 5/6. That would be my friend right here. Okay. And we were comparing that one there. And then I have to do 5/8. So I know that this would be 4/8. 4/8 is halfway. So I need to divide that in half, divide that in half, divide this in half, divide this in half. And so again, you kind of see these issues here. So this would be 5/8. And so comparing them, I can see that 5/6 is the furthest to the right. So 5/10 is to the left of 5/8. You can see the 5/10. It is to the left, so that means that 5/10 is definitely the smallest. 5/8 is to the left of 5/6. So from least to greatest, 5/10, 5/8, 5/6. And then lastly, I kind of did this in the last example. Again, we're using number lines, but we're going to use benchmarks 0, half, and 1. And you did notice me use the half. Now, half isn't always half. I mean, I use 4/8. Well, 4 is half of 8, so you could look at it that way. I can compare 3/4 and 3/8. Again, I got this number line thing going on, so if I'm going to do 3/4, I need 4 equal pieces, and I can just go like that. And so halfway is 2/4. This is 3/4. There's where that one guy would go. And then I have to do 8, which again I divide this and then divide these equally, and 3/8 is right here. And so you can see that 3/4 is definitely larger than 3/8. So 3/8 is between 0 and half. Okay, and what I can think about is, well, what is half of 8? Well, 4/8, so technically half is 4/8. Well, I know 3 is less than 4, so it has to be in this area here. And I know that 3/4 is greater than a half, because that would be 2/4. So I know it has to be somewhere in this area. And so that's just a way of thinking about it. So 3/8 is less than 3/4. Now, all in all, you maybe don't want to draw these things out. When you have different denominators, it still goes with our previous lesson, where we were talking about unit fractions. And so when I have 1/6, I know that is smaller than 1/4 or 1/4, because I know that this is divided up into smaller pieces. The same idea if I have 3/6 versus 3/4. The piece sizes still matter. I know they're both going to color 3 in, but again, I know that that 6 is divided into smaller pieces because we need to make more pieces out of the same thing. So if you don't want to do all this work with number lines, paper strips, etc., all you have to do is look at the denominator, and if it is a larger digit, 6, over this 4, I know that it will be less than the 4, which has less, the digits smaller in a sense, so the piece sizes will be larger. I'm going to get you to try this one using whatever method you'd like. Compare 2/8 and 6/8. Pause it, come back when you're ready. All right, so to make this easier, I did visually show this, and so with the denominator being 8, they're both 8 equal pieces, so I am coloring 2 in, and I'm coloring in 6 in, and so I can see that 2/8 is less than 6/8. This time, I'd like you to try one with the denominator being different, so the piece sizes are different. I'd like you to compare 2/4 and 2/6. Pause it, come back when you're ready. All right, so I did divide some bars if you think that way. I have 2/4 and 2/6. Just straighten that out. I can see that this is a 6. I know that the pieces are smaller if I have to have 6, so just off the bat I know that 2/6, it will be the smaller. If you did the number line with benchmarks or not, if I have to divide this into quarters, 4 equal pieces, I know that's 1/4, half, and 3/4. In other words, this is 2/4, and I can see that this would go here. But the other one I have to divide into 6, and so half of 6 is 3, so this has to be 3/6. So I have to divide this like so, and I'm doing 2/6, so that would be right here, and I can see that 2/6 is indeed smaller. So 2/4 is greater than 2/6. All right, so what we're looking at here today is comparing and then possibly ordering them in order from greatest to least or least to greatest, depending what the question says. If you have the same denominator, that's a little bit easier. Whatever the higher numerator is the bigger fraction. But if the denominator is different and the numerator is the same, like this, what's on the screen right now, you have to look at the piece size, because the higher the digit means it's divided into more pieces. Those pieces are getting smaller, therefore that is a smaller fraction. I really hope that works for you, and please remember, in life, math happens. Take care.